Hey, we miss you guys. If you weren't here in the last week, this is the quality work that we did without you guys. I know you're going to love those. You can see some really attractive pictures of us as grown-ups. Nice. Anyway, we're going to start on algebra. So I just want to take you back, have a look at the stuff that we did in grade 7. Some of you are going to say, why? Why do we need algebra? So we use an algebra all the time in our everyday lives. And you can see I've drawn Sarah Jane's beautiful cat here. So if Sarah Jane sells her cat on Facebook for like $27 and some guy comes and gives her a $50 note, Sarah knows that she needs to give this guy a certain amount of change. And until she knows what amount that is, we can call it X amount of change. We can call it Y amount of change. We can call it anything you want, but in algebra, we often use letters, okay? So Sarah Jane knows that 27 plus something is going to give her 50, and she can figure out that she has to give $23 change to the person who bought her cat. That is basically algebra. You are using it all the time in your everyday life. When you are throwing stuff into the bin, you have to figure out the weight of the object, the trajectory, force, all that kind of stuff. You are using algebra to figure that out. And sometimes when you throw something in the bin, it doesn't land in there. People will have another go, okay, and either use more force or less force, depending on how their throw went. Even dogs can use algebra when they're like at the park, catching a frisbee or something. What an excellent diagram. So if a dog can do algebra, all of you can also do algebra. If you're cooking and you're converting like pounds to kilos for sugar when you're making jam and all that kind of stuff, that is also algebra. If you're like a painter or a groundsman or something, you need to figure out how much paint you need for however much space, okay? You're using algebra. It is just patterns. So if I had a basic pattern like this one here, throwing stuff around, you can see that the pattern is just that you're adding 3, okay? You can also write that as x plus 3, okay? It doesn't have to be an x. You can make it a smiley face plus 3, a z plus 3, a diagram of a disabled looking man there plus 3. We can just use the letters to fill in for whatever we don't know, okay? Remember when you're doing algebra, we're doing these nice curly loopy x's, because otherwise it's really confusing with multiplication. And so you've got 3x plus something and it looks like 3 times plus something. All right. Now back in grade 7, you would have done stuff like this. Okay, we've got our matchsticks triangles. And you can see the number of triangles, there's one triangle here, and you can see 1, 2, 3, it takes up 3 matchsticks to do that, okay? It's really easy to figure out that it's the amount of triangles times 3 is your answer. And so you can also write that as x plus 3. So we don't need to draw 10 triangles for us to figure out that 10 times 3 means we're going to need 30 matchsticks to fill that in, all right? You looked at input and output tables, okay, and you can see the patterns here. So 3 and 8, 5 and 10. Most of you could figure out pretty quickly that the pattern is that we're adding 5. So where we input a 3, we add 5, okay, and we get 8. Same, same, same. And whatever number you put here, you could easily figure out that you can just add 5 and that's going to be your output. You can obviously do more than one step, and we did that last year in grade 7, okay? So you might times by 8 and then minus 2. So 1 times 8 is 8, minus 2 gives you 6, okay? And there's a couple more examples here. But then there's different ways of writing it as well. So we learned last year, okay, that you can write this in a number of different ways that all mean exactly the same thing. When you're timesing by 8, and you take away 2, okay, you could call your input x and you could call your output Why? All of those things look complicated when they're written like this, but everyone can see that this is really easy to understand when it's in this kind of format. So this year we kind of step away from that a little bit. So what we do in grade 8, we're going to look into substitution, if I can say that. And we're going to talk about our class group. So our class group has Q amount of students, okay? And Q is what we're using to represent our number because you guys aren't here. Oh, sad times. And I can't just count you, okay? So we're saying that we have Q amount of students in our class. Now, what if 5 students moved? Obviously, I'm a bit of a bully. I want to go to a nicer teacher. Our expression would then be Q take away 5, okay? Not too tricky so far. What if I started giving out lollies and our class size doubled, all right? We could have the expression as 2Q. Now, some of you are going to want to write 2 times Q, okay? It's the same thing, but one of the tricksy things we do in algebra is we don't bother to write in the times. You've seen that a number of times. But please remember, you only do it with times, you don't do it with addition. Now, what if we got 15 new students, okay? So that expression would look like Q plus 15. You don't do 15Q, okay, because that would obviously be 15 times Q. Now, what if another class had 7 students more than us, okay? The expression we would use would be our original Q plus 7, all right? Q plus 7. If 8P... Okay, we don't have an 8P, we only have 8B and C, don't get confused. An imaginary class has Q students plus 14, what does it mean? Okay, that obviously means that they have 14 students more than we do in our class group. If Mr. Gale has Q minus 3, that would mean that he has 3 students less than us. All right. Now, if we had Q over 2, that starts to look quite complicated. Obviously, like with a fraction, 1/2 is the same as having 1 divided by 2. Q divided by 2 means that the class has half the students that we do in our class. And if I had Q over 3, it would mean 1/3 of the students, or the amount of students that we have divided by 3. All right. So that is just what we are doing.